Students, this is Unit 6, Lesson 6.3, Rectangles, Rhombis, and Squares. Oh my. Quick review. It says right here you have a parallelogram. Solve for the variables x and y. Problem 2, read and solve. Hit pause on the video, do your work, and then restart with the red pen in hand. Pause. Welcome back. Let's take a look and see what happened here. What you should have noticed is that if you add these together, we get a 135. And if that's 135, this is also 135. And then taking here, these angles are what are called consecutive interior, which means they add up to 180. So we're going to go 135 away from 180. And you have 45. So this is 45. So to solve for y, you should have did 5y equals 45. Of course, y equals 9. Coming down here for x, that's 7x minus 5 equals 45. That's 7x. And then you add the 5 on both sides, and that's 50. And you divide by 7, and lo and behold, you have a decimal. You probably thought it was wrong, but it is not. So 7 goes into 50. And then, of course, the highest number there is 7, and that's 49. And 10, that goes in there one time. And you get a 3 left over, and that's a 4, so 7.14. Taking a look down here, it says if a regular polygon, poly, you do not know n. N is your question mark. Regular polygon has an exterior angle, so one exterior angle equals 360 over n. So this 36 degrees goes over here. 36 equals 360 divided by n. Pop this over 1, cross multiply. Your n equals 10, therefore it is a decagon. So last class we talked about the qualities, OCD qualities of a parallelogram. The OCD qualities. And of course the first one is that opposite sides are parallel. Opposite sides are congruent. Opposite angles are also congruent. Consecutive angles are supplementary or adds up to 180. Last but not least, of course, is that the diagonals bisect each other, which means this is the midpoint going both ways. So the diagonals bisect each other. These are the essential qualities of a parallelogram. Now the next 3 shapes that we're going to study all qualify as parallelograms, but they're types of parallelograms. So the 3 that we're studying are a rectangle, a rhombus, and then a square. So to get a rectangle, you start by taking a parallelogram and you make 4 right angles. So if you start with the parallelogram and you make 4 right angles, you get yourself a rectangle. So one of the definitions of a rectangle is a rectangle is a parallelogram with 4 right angles. A rectangle is a parallelogram with 4 right angles. So the 4 right angles is what makes a rectangle a rectangle. Here's another R-shaped rhombus, which some of you might know as a diamond. You take again, a parallelogram, and this time, instead of making 4 right angles in the corners, you make 4 congruent sides. You make all the sides equal. So a rhombus is a parallelogram with 4 congruent sides. So the essential part of a rhombus is 4 congruent sides. So recap here, a rectangle is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. That makes a rectangle and a rhombus unique. 4 right angles, 4 congruent sides. Now, here we have a parallelogram. So part of the parallelogram family is a rectangle. And then you have a rhombus. So they have all the qualities of a parallelogram. It's very important. In other words, they have all the OCD qualities. What makes a rectangle by definition unique? A rectangle is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. This is the quad family tree. Eventually, you're going to be memorizing this. We're going to be focusing just down here on this side in what's called the parallelogram family tribe. So a parallelogram, a rhombus, and a rectangle are parallelograms. And you're going to see here that if a rhombus and a rectangle get married and have a kid, their kid is a square. So a rectangle, 4 right angles, and a rhombus, 4 congruent sides. They get married, they have a kid, and the kid's name is a square because a square qualifies as a rectangle. It also qualifies as a rhombus. It has the characteristics of both a rectangle and a rhombus. And everything has the characteristics of a parallelogram. So there are some unique qualities, things that are also true of a rectangle in addition to the 4 right angles. A couple things you should be familiar with. Because you have the right angles, that red diagonal and that green diagonal, I like you to draw them in. Okay, I'd like you to physically do this. Please take the time to physically do what I'm about to do, okay? Put a thumb and a finger here, finger pinch that, the distance, finger pinch that distance. Okay, now hold that distance and compare it to the green dots. Compare the length of the red using your fingers, finger and thumb, pinch it. Compare it to the green, finger and thumb. You should notice here that the diagonals are congruent lengths. The diagonals are congruent in length in a rectangle. That's very important. That's unique to a rectangle. Now come over here to the rhombus. Once again, draw on the diagonals. Now, the diagonals here are not of equal length. They're not of equal length. There's a shorter one and a longer one, but they do have a couple unique qualities. And the unique qualities in a rhombus is that the diagonals actually do cut these corners in half. That does not happen in a rectangle. It cuts these corners in half. And most importantly, you have perpendicular diagonals. Now, those unique qualities of diagonals in both a rectangle and a square a rectangle and a rhombus all happen in a square. So in a square, draw on your diagonals. Finger pinch these. Put your finger, compare those distances. Now swing it around and compare this distances. So like a rectangle, the diagonals are congruent in length. Like a rhombus, the diagonals cut the corners in half. And we have a right angle in the middle, like a rhombus. So a square has all the qualities of both a rectangle and a rhombus. So take a moment, and I would go ahead, pause the video, and just verbally recite what are these qualities. You need to know these qualities here. Just take a moment, see if you can memorize them. You're going to be tested on these next class. Heads up, you're going to be tested. What are the qualities of a parallelogram? What makes a rhombus a rhombus? What makes a rectangle a rectangle? And then, of course, what makes a square a square? Pause the video, rotate your preview notes, take a close look at that for about 2 or 3 minutes, and then restart the video. All right, welcome back. Students, I really hope you took 2 or 3 minutes to try to memorize those. Now we're going to do some practice problems together. Let's read this out loud. Put your finger right there. In the rectangle below, trace and mark the given information on the diagram. Then find all possible angles and sides. So I have the list of what makes a rectangle right here. 4 sides, angle sum 180. Here's the OCD qualities. And then what makes a rectangle unique qualities. Diagonals are congruent in length. You have 4 right angles. So knowing all of that, let's work this problem out. We are told we have a rectangle, EFGH, and E to I is 2x plus 1, and F all the way to H is 3x plus 10. And then we're told that IFG, there's I, go to F, go to G, that angle right there is 51 degrees. Alrighty, let's start with a thing equation, and it all goes back to these qualities. Okay, because this is a midpoint. Why do I know I is a midpoint? Going both ways, because the diagonals bisect each other. And because F all the way to H is the same as E all the way to G, that's because the diagonals are congruent in length. I know this, that FH is equal to 2 of EI. I know 2 of the reds fit in 1 of the blues. So now we circle, plug, chug. FH and you solve. Now, it's important to actually check your work and see if you're correct. So if we're saying X is 8, let's check here. E to I, that's going to make that 2 times 8, which is 16, plus 1, that makes E to I 17. Let's check over here. It says that 3 times 8 is 24, plus 10 is 34. So we're going to go in here and see if this is a true statement. This is 17. That's 17. That means this is also 17. This whole thing is 34. And look, 2 times 17 does equal 34. So that's how we know our lengths are done. Now, at least on the inside. Now let's take a look here, close look. Let's take a look. We're going to find angles now. Because this distance is the same as that distance, and because we have a midpoint going both ways, we know all 4 of these pieces are of the same length, which makes this right here an isosceles triangle. If you have 2 equal sides, you have 2 equal angles. So if this is 51, this is 51. Now remember, it's a parallelogram, which means you have parallel lines. And if you have parallel lines, you also have armpits of the Z going on. So armpits of the Z means your 51 goes here. Armpits of the Z. You also have this way, armpits of the Z. That means the 51 Do you see that you have a right triangle? So let's pull out this right triangle. We have 51 degrees, and then this is 39. And we want to find two lengths here. We're going to call this length here X, right there, and we'll call this length Y. Now, it doesn't matter which angle we work with, either the 51 or 39, it doesn't matter. I'm going to pull this down here. Now we're back to using right triangles. I'm going to choose the 39. So from the 39, this would be opposite. This would be adjacent. And you're like, but we need a side length. We have this side length. This side length here is 34. And that would be our hypo. So I'm going to go for X over here and Y over here. So under X, I have the hypo and I want the opposite, OH. So I know that's a sine. So sine of theta over 1 equals opposite over hypo. So I see here I'm going to end up doing sine of 39 times 34 will give me X. $39 sine times 34, and we're going to take that to the second decimal place. That's 19.55. So X equals 19.55. Now we're going to go for Y. Y, I'm dealing with adjacent and hypo, so that's cosine. Cosine 39. Cross multiply. So we have cosine 39 times 34. Take it to the second decimal place. I have 27.82. Now, if you go back, what's really nice about this is it is kind of drawn to scale. So when you solve for X, X is obviously the shorter side. So this is going to be 19.55, 19.55. This is 27.82, 27.82. And then here, if you look, that's 34. 34 is the longest of the right triangle, which makes sense because the hypo is always the longest. My friends, look very, very carefully. We got all of this page simply because of that one simple word. It's a rectangle. A lot of information. Okay, let's try another one using a rhombus. I've got a rhombus. So keep in mind the characteristics of a rhombus. These simple characteristics: 4 sides, angle sum 360, has all of the OCD qualities, and in addition to, it has these 2 very unique qualities, which is the diagonals are perpendicular, which means we have right angles in there, and the diagonals also bisect the opposite angles. So let's mark that information on here. Let's see what we've been given. We've given that PR is 10. Right off the bat, because I know T is a midpoint, how do I know that? Because diagonals bisect each other. I'm just going to write 5 and 5 right off the bat. I'm not even going to bother writing down the 10 because T is a midpoint. QR is 13, so QR is 13. And the measure of TQR is 23. TQR is 23. Find everything possible. Notice that sponge there. I don't even tell you what to find. Let's do the angles first because the angles are easy. If this is 23 and this is a bisector, this right here must also be 23. And if opposite angles are congruent, which we know because it's also a parallelogram, that means this is 23 and this is 23. I have a right angle in the middle. So I can do this here, add up 23 and 90 and take it away from 180. Or I can simply do 90 minus 23. And we get 67. Because it's a rhombus, the diagonals cut the corners in half. 67, 67, 67. Great, we got all the angles. What are we missing here? We're missing our side lengths. A rhombus, by definition, is a parallelogram with 4 congruent sides. So if one side is 13, we can do all of these sides are 13, because that's what makes a rhombus a rhombus. Now look very carefully. You only have one additional item that we're unable to find, and that's this length right here. What do we have going on here? Trace that. Trace QTR. Do it again. Trace QTR. Do you see the fact that we have a right triangle, friends? I'm going to call this X. Let me pull it here so it's easy to see. That's X. 13. 5. Right angle. 23, 67. Now, take a look. I have angles and sides, which means I could use SOHCAHTOA, but I also have 2 sides and I need a 3rd side. So you could use SOHCAHTOA or Pythagorean theorem. We have 2 sides, need 3rd side. I think that's a little faster, so that's going to be leg squared plus leg squared equals hypo squared. Our one leg is X. Our other leg is 5. And our hypo is 13 squared. So you use Pythagorean theorem. And we solve for that last side. In the square below, the only thing you've been given is the fact that AC is 12. I want you to find everything possible. Pause the video, do your own work, and then restart. Let's see what you came up with. Because that is a midpoint, we know that's 6 and 6. Diagonals are the same length. This is also 6 and 6. I know I have right angles. Because it's a rectangle, I also know those right angles are being bisected because it's a rhombus as well, which makes all of these 45, 45, 90 triangles. "45, 45, 90, leg, 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 root 2. Alrighty, I'd like you to correct what you remembered and what you did not remember. Write yourself a note. I do recommend you take 2 minutes now, go back and verbally recap what did you learn on each and every page.